NASA is poised for a significant moment in its ongoing partnership with SpaceX as it prepares for the Crew-9 mission's return to Earth from the International Space Station ISS. This highly anticipated event will be marked by live coverage beginning at 10:45 p.m. Eastern Daylight Time on March 17, 2025, with a focus on the spacecraft's hatch closure preparations. The Crew-9 mission, which includes astronauts Nick Hague, Sunita Williams, Butch Wilmore, and Russian cosmonaut Aleksandr Gorbunov, has been critical in advancing scientific knowledge through various experiments conducted in the unique environment of space. The return, originally scheduled for later in the week, has been adjusted due to favorable weather conditions anticipated off the coast of Florida, underscoring the dynamic nature of space operations. NASA and SpaceX officials met to evaluate conditions and now aim for an earlier splashdown opportunity on March 18. This decision not only facilitates a timely return for the astronauts but also allows them to complete necessary handover duties before the expected deterioration of weather later in the week. Mission managers have emphasized the importance of real-time monitoring of multiple factors, including weather, sea states, and spacecraft readiness, all of which are crucial for ensuring a safe undocking and splashdown. The specifics of the splashdown location will be confirmed closer to the event. Viewers can follow the mission's progress through NASA's live operations, available on NASA Plus and various social media platforms. In a parallel development, NASA is navigating significant organizational changes back on Earth. The agency recently received a one-week extension from the White House to submit its workforce reduction plans, a response to ongoing missions and the operational demands they entail. NASA's acting administrator Janet Petro highlighted that the agency is committed to reshaping its workforce while ensuring efficiency and effectiveness in its operations. This comes in the wake of a presidential directive aimed at optimizing government workforce structures, which has led to discussions about potential layoffs across various agencies, including NASA. The implications of such workforce reductions are far-reaching, particularly in a time when NASA is preparing to launch several key missions, including the Crew-10 launch scheduled for March 22. Concerns are mounting within the space community regarding rumored budget cuts, especially a proposed 50% reduction in NASA's science budget for fiscal year 2026. Experts, including former NASA chief scientist Jim Green, warn that such drastic cuts could jeopardize the United States' leadership in space exploration and hinder scientific advancements critical for economic growth. Amidst these challenges, innovative projects continue to thrive. A team from Embry-Riddle Aeronautical University is contributing to NASA's Dragonfly mission, which aims to explore Saturn's moon Titan. This mission represents a pioneering effort to study Titan's unique atmosphere in prebiotic conditions, with the Embry-Riddle team focusing on the rotorcraft's aerodynamics to ensure successful operations. Supported by a NASA contract, the research aims to refine the design of the rotorcraft, allowing it to navigate the moon's diverse terrain and gather valuable scientific data. As the Crew-9 mission prepares for its return and NASA grapples with potential workforce changes, the agency remains at a crossroads. The decisions made in the coming weeks will not only influence the immediate future of its missions but will also shape the broader landscape of U.S. space exploration. Stakeholders are closely watching how these developments unfold, with the hope that NASA will continue to inspire and lead in scientific discovery and technological innovation. NASA is preparing for a highly anticipated event as the agency announces live coverage of the SpaceX Crew-9 return to Earth from the International Space Station ISS. The mission, which has kept its crew in orbit for an extended period, is set to culminate in a splashdown off Florida's coast on Tuesday, March 18, with preparations beginning as early as Monday night. The Crew-9 team, comprised of NASA astronauts Butch Wilmore, Sunita Williams, and Nick Hague, alongside Roscosmos cosmonaut Aleksandr Gorbunov, has been conducting scientific research aboard the ISS. Their mission, originally expected to last a short duration, has turned into a remarkable 9-month journey due to unforeseen circumstances surrounding the Boeing Starliner spacecraft. This capsule, which was to bring Wilmore and Williams back home after their initial 10-day mission, experienced propulsion issues, forcing NASA to delay their return. NASA's mission managers have been closely monitoring weather conditions to ensure a safe return, adjusting the splashdown timeline based on favorable forecasts. The updated return target continues to allow the space station crew members time to complete handover duties while providing operational flexibility ahead of less favorable weather conditions expected for later in the week, a NASA spokesperson stated. As the Crew-9 mission approaches its conclusion, the agency is committed to ensuring a successful and safe homecoming for its astronauts. Beginning on Monday, March 17 at 10:45 p.m. Eastern Daylight Time, NASA will provide live coverage of the Crew-9 hatch closure on NASA Plus. This will be followed by undocking at 1:05 a.m. Eastern Daylight Time on March 18 and coverage of the deorbit burn at approximately 5:11 p.m. Eastern Daylight Time, leading up to the projected splashdown around 5:57 p.m. Eastern Daylight Time. The journey back will also feature a media conference at 7:30 p.m. Eastern Daylight Time, highlighting insights from NASA and SpaceX officials regarding the mission's achievements and challenges. Wilmore and Williams' extended stay has drawn significant media attention, with both public and political figures expressing concern over their prolonged absence from Earth. The duo was characterized as stranded by notable figures including President Trump and SpaceX CEO Elon Musk, highlighting the unexpected nature of their situation. As Wilmore remarked, "It was a wonderful day. Great to see our friends arrive," referring to the recent arrival of their replacements. Who will take over operations at the ISS? The Crew-10 mission, which delivered the new astronauts to the ISS, represents a crucial step in maintaining continuous human presence aboard the station. As the Crew-9 members prepare for their return, they will leave behind a bustling lab with a total of 11 crew members representing the US, Russia, and Japan. The Crew-9 mission is a testament to the complexities of space exploration, characterized by technical challenges and the need for adaptability. As the astronauts ready themselves for their journey home, the space community is eager to witness the successful return of Wilmore, Williams, Hague, and Gorbunov. This event not only marks the end of an extraordinary mission but also highlights the ongoing collaboration between NASA and SpaceX in pushing the boundaries of human spaceflight. Looking ahead, the successful completion of Crew-9's return may pave the way for future missions, further enhancing our understanding of long-duration space travel and the resilience of astronauts in the face of unexpected challenges. As we await their splashdown, the excitement around the mission serves as a reminder of humanity's relentless pursuit of exploration and discovery beyond our planet. NASA is gearing up to provide live coverage of the anticipated return of its SpaceX Crew-9 mission, marking a significant milestone in the agency's ongoing collaboration with commercial space partners. As astronauts Butch Wilmore, Sunita Williams, Nick Hague, and Roscosmos cosmonaut Aleksandr Gorbunov prepare for their return from the International Space Station ISS, excitement is building around this critical moment. The live coverage is set to begin with the Dragon spacecraft's hatch closure at 10:45 p.m. Eastern Daylight Time on March 17, with the expected splashdown taking place off Florida's coast on the evening of March 18. The decision to adjust the Crew-9 return timeline was made after a thorough assessment of weather conditions, which are currently favorable for splashdown. Our mission managers are targeting an earlier Crew-9 return opportunity to allow the crew time to complete their handover duties while also providing operational flexibility ahead of less favorable weather conditions expected later in the week, NASA stated in a media advisory. The crew of Crew-9 has been engaged in a long-duration scientific expedition aboard the ISS, conducting critical research that will be returned to Earth. As they prepare to undock, mission managers are closely monitoring various factors including spacecraft readiness and sea states to ensure a safe return. NASA and SpaceX are expected to confirm the specific splashdown location as the return date approaches. In a press conference, both Wilmore and Williams expressed their eagerness to return home after nearly 300 days in space, far exceeding their original 8-day mission plan. Williams reflected on her time in space, stating, "Everything about this experience has been incredible. It's a unique perspective that I will cherish forever. However, she acknowledged the challenges of uncertainty, mentioning that the hardest part has been the prolonged wait for their return amid a series of technical difficulties with their original spacecraft, the Boeing Starliner. The return of Crew-9 coincides with the arrival of NASA's Crew-10 mission, which successfully launched on March 12 and docked at the ISS on March 17. This new crew, consisting of NASA astronauts and McLean and Nicole Ayres, JAXA astronaut Takuya Onishi and Roscosmos cosmonaut Kirill Peskov, will spend the next 6 months conducting experiments and supporting ongoing operations aboard the station. Their arrival has set the stage for a smooth transition as Wilmore and Williams prepare for their long-awaited homecoming. NASA's live operations coverage will be accessible on NASA Plus, with events scheduled throughout the return process, including a media conference to discuss the landing. As the agency continues to navigate the complexities of human spaceflight, the successful return of Crew-9 underscores the importance of collaboration between NASA and commercial partners like SpaceX. Looking ahead, the successful completion of the Crew-9 mission will pave the way for future expeditions and further developments in NASA's Commercial Crew program, which aims to enhance access to low Earth orbit and expand scientific research opportunities. With both Crew-9 and Crew-10 now operational, NASA is set to continue its legacy of pushing the boundaries of space exploration while ensuring the safety and readiness of its astronauts. As the world watches the upcoming splashdown, the excitement for what lies ahead in human spaceflight continues to grow. In an exciting development for space exploration, a team from Embry-Riddle Aeronautical University is playing a crucial role in the design of NASA's Dragonfly mission, which aims to explore Titan, Saturn's largest moon. This groundbreaking initiative will utilize a unique rotorcraft lander to investigate Titan's prebiotic environment and the potential for life beyond Earth. The project is bolstered by a $475,000 contract from NASA's New Frontiers program awarded to Dr. Michael Kinzel, an associate professor in Embry-Riddle's Department of Aerospace Engineering. The Dragonfly mission is an ambitious endeavor that will see the rotorcraft lander equipped with advanced instrumentation designed to measure various aspects of Titan's atmosphere and surface. According to Dr. Kinzel, the mission's primary objective is to enhance our understanding of the early conditions that may have fostered life on Earth. We are the first group to bring high-fidelity computational models of fluids to the mission, Kinzel stated, emphasizing the innovative approach of using high-performance computing to simulate the aerodynamics of the Dragonfly in Titan's unique atmospheric conditions. Titan has garnered significant interest from scientists due to its complex environment characterized by a dense atmosphere, methane clouds, and surface features resembling those found on Earth. The Cassini orbiter has provided tantalizing insights into these features, revealing lakes, seas, and organic materials that may serve as the building blocks for life. The research team, including graduate research assistant and PhD student Jackson Asiatico, is focused on accurately characterizing the aerodynamics of a vehicle designed for an environment that is both unfamiliar and extreme. Our work is crucial for ensuring that the vehicle can perform its scientific operations effectively, Asiatico noted. The team is currently using NASA wind tunnel data to refine their models and enhance the design of the rotorcraft's fuselage. They are also investigating how the rotorcraft will interact with Titan's dusty surface, which is covered in massive sand dunes that can reach heights of up to 100 meters. Understanding the sand character enables scientists to infer the prevailing winds that shape these dunes, Kinzel explained, which could provide further insights into Titan's atmospheric conditions. Dr. Richard Prazenica, interim chair of the Aerospace Engineering Department, praised the team's efforts, highlighting that their research is not only vital for the Dragonfly mission but also contributes to the broader field of aerospace engineering. The collaboration extends beyond Embry-Riddle, with Johns Hopkins Applied Physics Laboratory leading the design of the Dragonfly rotorcraft in partnership with Penn State and Sikorsky, a Lockheed Martin company. As the Dragonfly mission progresses, Kinzel and his team are optimistic about the potential discoveries that await on Titan. The unique characteristics of Titan's environment offer an unparalleled opportunity to explore fundamental questions about the origins of life and the processes that shaped our own planet. In a separate but equally significant development, a new NASA study has revealed alarming trends in California's land movement, with certain areas sinking into the Pacific Ocean. Research from NASA's Jet Propulsion Laboratory (JPL) and NOAA indicates that the Central Valley is particularly affected, with some regions sinking by as much as 8 inches per year due to groundwater extraction exacerbated by the ongoing drought. This phenomenon poses a serious risk to coastal cities, especially as sea levels continue to rise. Marin Gavorson, a remote sensing scientist at JPL, explained, "In many parts of the world, reclaimed ground is sinking faster than the sea is rising, highlighting the urgent need for effective monitoring and adaptive strategies in response to these changes." The study also found that significant movements are occurring along the San Francisco Bay, where some coastal areas are experiencing subsidence of over 0.4 inches annually. As California grapples with these geological challenges, the study underscores the importance of continuous monitoring to help communities adapt to the realities of rising sea levels and land instability. The implications of this research extend beyond California, with similar sinking issues reported in cities like New York and Chicago, indicating a widespread challenge that demands attention. Looking ahead, the collaboration between Embry-Riddle and NASA on the Dragonfly mission promises to deepen our understanding of Titan and its potential for life, while the findings from the JPL study serve as a catalyst for urgent discussions on land management and climate adaptation strategies. Both initiatives reflect the critical intersection of aerospace research and environmental science, paving the way for future innovations and discoveries in our quest to understand both our celestial neighbors and the challenges we face on Earth. NASA's Perseverance rover has made headlines once again by collecting a rock sample dubbed Silver Mountain, which boasts textures described as unlike anything we've ever seen before. This finding marks the rover's 26th sample from Mars, reflecting a broader initiative to unravel the mysteries surrounding the planet's geological history, climate, and potential for past life. The Silver Mountain sample has been secured in a tube for future analysis on Earth, with NASA projecting that these samples could be returned by as early as 2035. Former NASA Administrator Bill Nelson emphasized the importance of this mission, stating, "Pursuing two potential paths forward will ensure that NASA is able to bring these samples back from Mars with significant cost and schedule saving compared to the previous plan." This strategic decision underscores the agency's commitment to Mars exploration, particularly under the leadership of billionaire Jared Isaacman, who has indicated that Mars will remain a priority. Perseverance, affectionately known as Percy, has completed its ascent out of Jezero crater, where it landed in February 2021, an area believed to have once been hospitable to microbial life. As it traverses the northern rim, the rover is set to explore 4 sites of significant geological interest while collecting additional samples. To date, it has traveled over 20 miles, meticulously mapping its path on NASA's interactive platform. Nikki Fox, who heads NASA's Science Mission Directorate, remarked, "This will also prepare us to safely send the first human explorers to Mars." This focus on human exploration is crucial as NASA aims to establish a sustainable presence on the Red Planet. In related developments, seismic data from NASA's InSight lander has provided compelling evidence that Mars may harbor substantial quantities of water buried deep beneath its surface. Researchers have indicated that liquid water could exist 6 to 12 miles underground based on the behavior of seismic waves detected during Marsquakes. Ikuo Katoyama from Hiroshima University stated, "Many studies suggest the presence of water on ancient Mars billions of years ago. But our model indicates the presence of liquid water on present-day Mars." Such findings not only bolster the case for past life on Mars but also raise the tantalizing possibility of current microbial activity. In another intriguing turn, NASA's Curiosity rover has sent back stunning visuals from its ongoing explorations on Mars. A recent image shared on social media showcased the rover against the planet's rugged terrain, igniting excitement among space enthusiasts. However, the image's clarity has sparked debate, with many speculating whether the blur was due to data compression or a technical glitch. Regardless, Curiosity's mission since its landing in 2012 has yielded invaluable insights into Mars' geological past, further laying the groundwork for future human missions. Adding to the excitement, the Perseverance rover has discovered a peculiar rock formation near an ancient riverbed characterized by poppy seed and leopard spot patterns. This geological anomaly potentially indicates past microbial life, as the iron oxidation patterns within the rock resemble signatures linked to microbial respiration on Earth. While cautious optimism prevails, scientists stress that definitive proof of life will only come from thorough Earth-based analysis. As NASA's Mars sample return mission continues to develop, the stakes grow higher. The potential discovery of ancient life on Mars could redefine humanity's understanding of our place in the universe. The findings from Silver Mountain, alongside the evidence of subsurface water and intriguing geological formations, suggest that Mars may have once been more than a barren wasteland. The unfolding narrative of Mars exploration holds the promise of unveiling secrets that could reshape our understanding of life beyond Earth. With scientists eager to analyze the samples that will eventually make their way back to our planet. In a groundbreaking collaboration, a team from Embry-Riddle Aeronautical University is playing a pivotal role in the design of NASA's Dragonfly rotorcraft, which is set to explore Titan, Saturn's largest moon, in a mission slated for launch in 2028. This ambitious project aims to unlock the mysteries of Titan's unique environment and its potential for harboring the building blocks of life, making it a focal point for astrobiological research. The Dragonfly mission, supported by a $475,000 contract from NASA's New Frontiers program, is spearheaded by Dr. Michael Kinzel, an associate professor in Embry-Riddle's Department of Aerospace Engineering. Kinzel's team is utilizing high-fidelity computational fluid dynamics models to simulate the aerodynamics of the rotorcraft, a process that involves running extensive computer simulations to ensure optimal performance in the harsh atmospheric conditions of Titan. The data we gather will enhance our understanding of early life on Earth, Kinzel explained, emphasizing the significance of studying Titan's dense atmosphere, methane lakes, and organic materials. These features were highlighted in images captured by the Cassini orbiter, which revealed a world rich in the chemical precursors necessary for life. Graduate research assistant and PhD candidate Jackson Asiatico, who has been working alongside Kinzel since the project's earlier phases, noted, "Our work is trying to properly characterize the aerodynamics of a vehicle that has an unfamiliar shape and an unfamiliar environment so that it can perform its science operations." This challenge is underscored by the fact that Titan's surface includes vast sand dunes and rocky terrain that could impact the rotorcraft's functionality. The Embry-Riddle team is also investigating how the Dragonfly's rotors interact with Titan's surface, particularly regarding dust and particulate matter. Understanding how the rotors kick up dust can help us measure key characteristics of the dunes and infer the prevailing winds, Kinzel stated. This research could provide invaluable insights into Titan's atmospheric dynamics, further informing scientists about the Moon's climate and geological history. Dr. Richard Prazenica, interim chair of the Aerospace Engineering Department at Embry-Riddle, praised the innovative research being conducted by Kinzel and his team. Their work on the complex aerodynamics of the Dragonfly vehicle will lead to improved measurements and analysis of Titan's soil and environment, he emphasized, highlighting the importance of this project for the broader scientific community. The Dragonfly rotorcraft, designed by the Johns Hopkins Applied Physics Laboratory, will be capable of flying to multiple locations across Titan's surface, allowing for unprecedented exploration. This unique design, which resembles a large drone, will enable scientists to collect diverse samples and conduct various experiments that could shed light on the early conditions for life not only on Titan but also on Earth. As the 2034 mission date approaches, the challenges remain significant. Recent studies have revealed that Titan's winds are strong enough to roll boulders up to half a meter in diameter, potentially posing a hazard to the rotorcraft's operations. Researchers must address these environmental factors to ensure the mission's success. With the Dragonfly mission, NASA is not only seeking to explore a distant moon but also to expand our understanding of the fundamental processes that led to life on Earth. As Dr. Kinzel aptly noted, this is an opportunity to explore another world and learn about our own in the process. As research and preparation continue, the upcoming years hold the promise of significant discoveries that could reshape our understanding of life beyond our planet.